To solve equation A, which is basic differential equation of Terzaghi's consolidation theory, I am assuming U to be product of a function of Z and a function of T. That is U equal to f of Z into G of T. Okay. So from equation A, I need dou U by dou T and dou square U by dou Z square. So dou U by dou T becomes f of Z into dou by dou T of G of T. So that is f of Z into G of T, and dou square U by dou Z square comes to be f double dash of Z into G of T. Now substituting these two in equation capital A, I get dou U by dou T, which means f of Z into G dash of T equal to C nu into dou square U by dou Z square. That is f double dash of Z into G of T. So if I rearrange this, I get f double dash of Z divided by f of Z equal to G dash of T divided by G of T into 1 by C nu. So let f double dash of Z be minus b square into f of Z. So which means f of Z equal to a1 cos bz plus a2 sin bz and g dash of t equal to minus b square c nu g of t, and g of t becomes a3 e power minus b square c nu t. Here a1, a2 and a3 both all are constant. So my u is f of z into g of t, that comes a1 cos bz plus a2 sin bz into a3 e power minus b square c nu t, and this comes a4 cos bz plus a5 sin bz into e power minus b square c nu t. So where a4 is a1 a3 and a5 is a2 a3. So the above equation I am taking as capital B. Now I will use the following boundary condition to solve equation B. My first boundary condition is at t equal to 0, u equal to ui, which means initial pore water pressure at any depth, okay, ui. And my second boundary condition is u equal to 0, z is equal to 0. And the third boundary condition is for u equal to 0 at z equal to ht, that is 2h. So this we have taken from starting of the equation, where h is length of the longest drainage path, and h is nothing but half of the total thickness of clay layer ht. So from this relation we get h is half of ht. Okay. substituting second boundary condition in B, we get u equal to a4 cos bz plus a5 sin bz into e power minus b square c nu t. For u equal to 0 and z equal to 0, we get 0 equal to a4 cos 0 plus a5 sin 0 into e power minus b square c nu t. That means a4 is 0 and u equal to a5 sin bz into e power minus b square c nu t. Now substituting u equal to 0 and z equal to 2h, that is, we are substituting third boundary condition. So we have obtained u as a5 into sin bz e power minus b square c nu t. So this becomes 0 equal to a5 sin 2bh e power minus b square c nu t, and entirely we get sin 2bh as 0. That means 2bh equal to n pi and b equal to n pi by 2h. So we can write u as sigma n equal to 1 to infinity an sin bz into e power minus b square c nu t. Sigma n equal to 1 to n equal to infinity an sin bz. We have obtained b as n pi by 2h, sin n pi by 2h into z into e power minus n square pi square by 4 into t nu, where t nu is non-dimensional time factor. T nu equal to c nu t by h square. Now substituting first boundary condition, that is t equal to 0 and u equal to ui, we get u as a5 into sin n pi by 2h into z into e power minus b square c nu t. So in this, ui equal to a5 sin bz e power 0. So I have obtained ui as a5 sin n pi by 2h into z. So to satisfy the boundary condition, ui should be equal to sigma n equal to 1 to n equal to infinity an sin n pi by 2h into z. So this is equation D. So equation D is nothing but a Fourier series, and A can be given by an equal to 1 by h integral 0 to 2h ui sin n pi by 2h into z dz. Now substituting an in equation C. Uh, so this is my equation C. So this is equation C. Substituting A and in equation C, I get U equal to sigma n equal to 1 to n equal to infinity. So 1 by h integral 0 to 2h ui into sine n pi by 2h into z dz, so into sine n pi by 2h z into, so I am writing here, into e power minus n square pi square pv by 4. So this is the final answer for u. So somewhat difficult but important. Simple mathematics, integrations and derivations. Thank you.